తెలియదు సార్. ఏం సార్? సరే సార్.
Good morning to all the dignitaries, respected faculty members, industry experts, and enthusiastic participants joining us from various corners of the country. A warm welcome to the inaugural session of the third day online faculty development program on AI-powered IoT and Python application in EV systems and charging networks, organized by Mother Institute of Engineering and Technology, Palanhayat.
This FDP aims to empower the faculty and researchers in emerging tools and trends in the EV domain with a special focus on AI-generated IoT systems and Python-based solutions. We thank you all joining the virtual and hope this week turns out into intellectual stimulation and practical enriching for every participant.
It is with great honor that we introduce our esteemed chief guest, Mr. Anirudh Bharathan, sir, Chief Innovative Officer at the Indian Institute of Information and Technology, IIT Kottayam. Mr. Anirudh is a highly accomplished innovator and technocrat with an academic background in electronics and communication engineering and a master degree in VLSI and embedded systems from MG University, Kottayam.
From working as a CAD engineer, to co-foundation startup focus on embedded systems, his journey has been marked by innovation and leadership. As ASIDD salary, he has led the FDP Snapchat to national recognition, and his current role at IIT Kottayam, he spearheads innovation-driven projects, including prestigious assignments for Indian Navy. He is multi-award winner recipient of Best Mentor Award, Top Performer Award, and Special Innovation Award, and serves as the Regional Mentor of Change under the Atal Innovation Mission, Government of India.
We are delighted and privileged to welcome such a visionary personality with us today to enlighten this community.
Thank you, Honorable. Hello, sir. Sir, you can take on the session, sir. You can take on the session, sir. Sir. Audio coming from your side that here, I'm not able to hear anything. So obviously, so that's why there is something or the caption is not.
Yes, please start, sir. Yes, sir. You can start, sir. Hello, sir. Can you hear, sir, from outside? Can you hear, sir, from outside? Honorable sir.
அது பிரச்சனை இல்லை, அது தாண்டாது.
Any other sir? Okay, you can start sir. You can start your session. We are hearing your voice. No, we can start a few giants to online also. You can start, sir.
No, நான் பேசிக்கிறேன். நான் பேசிக்கிறேன். Stay. Rohit, FDP. Rohit, Duty United are not free. Fight every.
Yes, you're So, good morning. So, today we are going to AI power interlocking. So, in the context of EV. So, basically, we start from then we will do some hands on exercise in interlocking, and then we will also AI accelerators. So, discuss about different types of accelerators used in artificial intelligence, especially in the context of interlocking. So, we will know about edge devices, space computing, and cloud computing. So, in IoT, mostly we will be using edge computing. Most of the AI powered IoT moves are edge nodes, edge-based nodes, especially in the case of the vehicles. So, we discuss about that, then we discuss the handle this. So, this is a session plan. So, you should interact with me, you actually interact with me, then only I will be able to properly plan the session. So, if you have any doubt, you can insert me and ask the doubt. Maybe there will be a handheld microphone over there, you can take the handheld microphone and interact with me. So, if without interacting, I will not be able to properly deliver the session. I'm not planning to deliver a one-way session, so it should be interactive. I will be able to do my best. So, I don't know from which teams they are coming from and what about your they are learning the working and the sessions. So, if you give me proper feedback, so I will do my best to convey it clearly and precisely. So that's what we are going to do. So I'll start from the main basics of embedded system and networking. Then we'll start doing some handling. So morning, nearly 1 hour waiting for the theory class. Then we move to the acting one. Will you share one please? The screen is good. So, moving on to AI power intelligence. To start with, let me start with the basic definition of interlocking. So, IoT. It's all about interconnected objects that are able to transfer data over a wireless network. So, interlocking is not mandatory to have internet interlocking. It can be any kind of wireless network. So, the central network or the central node will be the internet. So, other type of communication protocols is also available. Not exclusively, you can use CV protocols, we can use Bluetooth, we can use and communication between nodes can be using Bluetooth, Wi-Fi, LoRa, any application you can use. Even central node we communicate with it. Not mandated for all the nodes to communicate. So this is the basic concept of interlocking. And these are the activities. Interlocking is everywhere. In transportation and logistics, we can use interlocking. In marketing, we can use interlocking. In industry, we can use interlocking. So in agriculture, we can use interlocking. So in a lot of areas, we are using interlocking. You can see here, this is the first IoT enabled device. So this is a poster. This is the first IoT enabled device. No more. Embedded system. So this is a very important aspect. To learn artificial intelligence for all your things, to learn your things, you have to start from the beginning of embedded system. So I have a question. Searching for the audience, so please let me know what that is in from the audience. And as I said, you guys should interact with it. Based on your feedback, I will plan the session that I want to. Please let me know what that is in anyone? So I'm wondering, right? Is there any issue? Yes, please, anyone, what's the reason for this?
So which company performs the processing process?
The embedded system is a combination of hardware. The system is a combination of hardware and software. A combination of hardware and software intended to perform one or limited sets of functions. An embedded system is a combination of hardware and software intended to perform one or limited sets of functions. So this is a definition. So based on that definition, could you please let me know which one is our embedded system and which one is around embedded category? So we have A, B, C, D, E, F, G. So which one is our not embedded and which based on the definition, I will read the definition. Embedded system is a combination of hardware and software intended to perform one or limited sets of functions. So this is the definition. Based on this definition, this one is embedded and this one is not embedded.
So just to speak to this is the
considering answers in chat box, But I'm just asking for embedded and non-embedded application. So when you are giving an answer, be clear. Mean is an embedded system or mean is not an embedded system. It is an embedded system or a non-embedded application. Mention that also in the chat. And you can use it for questions. That's again, ambiguity yourself and explain. Which is an embedded system, embedded system, or which one that is not an embedded system. Make your code clear.
Sir, if you know the answer, please give it. Asking your question.
So basically, if you want to interacting, I will not be able to understand exactly your asking your. So that's why I'm being interacting. Otherwise, I won't be able to understand what exactly is happening over there. Since the online version is very hard for me to understand. See, I mean, so see, behind the words, and whatever number. Number system, C is a number system, D is a number system, E is a number system, F is also a number system. Okay. B, C, D, E, F, they are numbers. But what about A and B? A is a laptop, right? A is a laptop, which means just think about the location. And number system is which is integrated processor. It's a combination of hardware and software. Basically, yeah, this computer is a combination of hardware and software. Interesting. Fine. But what about the functionality? An embedded system is a combination of hardware and software, which is intended to perform one or limited sets of functions. So what about the functionality of the hardware for a laptop? We can perform n number of things in a laptop, and the functionality of the laptop is not limited. It's a general purpose system. And what about these? These are desktop computers. The functionality of these is not limited. We can perform n number of things using your laptop, and Z is also not a number. It's a general purpose. A is also not a number. It's a general purpose. So B, C, D, E, F, they are number systems. Why? Inside an AC, there is a microcontroller, there is a software running. That's the only reason why when you increase the temperature or when you decrease the temperature, AC is able to adapt accordingly. AC is your air conditioner adapt based on your temperature. So air conditioner will adapt based on your engine. Air conditioner will adapt based on the ambient temperature. This is possible only because there is a hardware and software inside AC. There are sensors inside AC. Okay. AC, air conditioner is never interesting. Definitely there is a microcontroller inside AC, and only because of that we are able to make an AC intelligent. Okay. See, the Mars rover. It's an emergency. It has got a microcontroller inside, the software is running inside. And that particular application is intended to perform only one application. So that's numbers. And what about the washing machine? Definitely, there is a microcontroller inside the washing machine. And only because of that, we are able to set timer in the washing machine. We are able to hear some beep sound from the washing machine, and when we get something, when the washing complete, we will know you feedback, right? That this is because of the microcontroller, which is residing inside the washing machine. And what about our TV? The TV is also an embedded system. And what about mobile? It is also an embedded system. So you can ask me, we can use mobile phone to perform multiple games. So how can you tell mobile phone and embedded system? So as I said, the functionality should be limited. functionality can be in terms of hardware or software. So just think about the hardware. Can we expand the RAM of a mobile phone? Not possible to expand the RAM of a mobile phone. You can increase the flash memory by 30 GB, but we can't expand the RAM of a mobile phone. Can we switch the operating system of a mobile phone? Can we change from iOS to Android? Can we choose from Windows from who's saying yes?
No.
I mean, what is the case? So when you are commenting something, make it clear. Yes, what is? That's what I'm asking. So regarding which statement you are listening, whether we like or not. Yeah. How can you change the operating? Can you change the iOS to Android from iOS to Android? So which means can you install Android operating system in your iPhone? How do you do that? So you can not in iPhone. So how will you port iOS to operating? Can you port iOS to Android? I don't know. Maybe any of the could go to code, but I don't know. Maybe I just know that you know. Maybe it's not possible. It's not flexible. So in multiple terms, in case of hardware and software, in multiple areas, the functionality of a mobile phone is. So you can use the number system. But it's a controversial statement. In internet, when you search for the tech guys are taking considering it as an embedded system, and some of the other guys are not considering it as an embedded system. So basically, there is a controversy happening in the tech world, whether to consider mobile phone as an embedded system or not in that application. So according to me, because of all this going, I am considering it as an embedded application. Because the functionality of a mobile phone is not that flexible like the normal PCs. So you can expand, if you can expand one, you can switch the operating system. So there are a lot of limitations, and the interface is limited. There will be one interface, the Type-C or USB interface. But in case of a development processor, there will be multiple interfaces including HDMI. So in all points of view, the functionality of a mobile phone is limited, so we can call it as an embedded computer. Moving on. Okay. This is the important part. So we are moving on to the important part, very important part, because the second topic is about AI powered internet. So how can you merge AI and internet? So that's what we want to discuss. So the next topic is very important. So here you answer me over here, okay? Just to give a feedback. So my question is, so you're using a mobile phone, okay? And that mobile phone is working because of a processing system inside that, right? So there is something inside a mobile phone performing the processing. That's the only reason why a mobile phone is working. My question is, why exactly is inside a mobile phone which is doing the process? The question is the eligibility. And it's straightforward. The question is, what exactly is inside a mobile phone which is doing all the processing? So you can do camera, you can take photos, you can send videos, you can stream videos, you can play games, everything is possible. Only because of something inside a mobile. What exactly is inside a mobile phone which is doing all this stuff? Yeah. I got an answer. I was So could you please let me know the name of the processor which is residing inside a mobile phone? Say it's a Samsung phone. Which processor will be used inside a mobile phone? Just name name of the processor. Yeah, quad processor. I don't know the quad processor. Any other processor? You mentioned about the quad core processor. Yeah, great. Exynos. Exynos is one manufactured by Samsung. Any other processor? It's all about the core actually. Number of cores, dual core, octa core. It's a core. It's not the name of the processor. Name means yeah. You would answer the Snapdragon. Snapdragon. Intel is not inside our mobile phone. Intel is specifically for manufacturing processors exclusively for general processors. And we have some embedded computers also. Inside the mobile phone, we have the quad core. Manufactured quad core, we have the Snapdragon, we have the fan. All the things are inside the mobile. Inside the mobile. These kind of processors are inside the mobile. Okay. So, I'm asking that is it just a processor? Is it just a processor? I mean, the Snapdragon, Exynos, all these things can be called as a processor or something else. Will you please let me know?
I think
So basically, it's not a processor actually. So when you talk about Snapdragon, it's not just a processor. Processor is just a component inside the chip. So here you can see this is the architecture of Snapdragon. So we have a Qualcomm GPU inside the processor. We have a crypto processor inside the processor. So we have a video processor in addition. We have a Qualcomm secure processor. So we have a display processing unit. We have a safety manager. And we have a neural processor.
Sir, one request from our side, sir.
Actual architecture.
Sir, can you hear me?
So processor is just a single row.
Sir, can you hear me? Sir? Can you hear me? Okay, one request from our side, sir. Sir, when we are switching mobile phone, when we are switching mobile phone and both Google Meet, it can disturb me, sir.
I'm not able to hear anything.
Can you hear me now? Can you hear me?
Yeah, now it's good.
One request, sir. One request from our side. Actually, if you switch on Google Meet as well as mobile phone, through mobile phone also, if you switch on disturbing is coming while we are asking question, while we are answering the question. So what we will do, sir, we will switch off at the time. When we are answering, sir, before answering the question, just what participants ask the question, sir, that question also just inform the question and you can answer, sir. Then it will be passed to all the participants, sir. No, you don't have to do anything, sir. When you are answering the question, please mention the question and answer, sir. Sir, when you are answering the question, no. Can I call and ask, can you repeat the call? I try to call you also. I'll call you, sir, through phone. I'll call you, please pick the phone.
I'm not able to before what you are saying. It's not one thing is audio is not really clear.
Yes.
And I'm not getting what you're saying. So, just let me know exactly I should do that. Okay, so just let me know. Hello? Okay, yeah, you will do that. Okay. So, coming back. So this is a system. What I'm trying to convey is that, so when someone asks you what exactly is inside what exactly is inside the mobile phone, what exactly is running inside the mobile phone, it's not just a processor, it's a system of software. So what exactly is the system of it? It's a system of it. You have integrated multiple when you the it was the single chip. It was single processor actually the system with multiple capacity. So we can just mention or we can just downscale a system onto calling it as a processor. Inside that there's a processor. Basically, when you speak, there will be microcontrollers, sensors, actuators, and elements. So this is a basic flow diagram of an embedded system. This is a basic flow diagram of an embedded system. Okay. Microcontroller, sensors, actuators, and elements. So now, what are the interesting concepts? So basically, we'll be programming microcontrollers. So you will have done programming laptop, you may have done programming using a browser, you may have done that using several ways. My question is, language. So which sort of language? In English is a type of so which sort of language is your comfortable? Which sort of language is your comfortable? So yeah, Python, C programming, most of them are familiar with Python. Okay. Normal language. language, only just Python and C. Okay. Anyway, so my question is, in case of Python as well as C, anything, no problem. So the question is general. So you have done your first program in Python. So what was your first program in your Python? What's it? Yeah, yeah, hello world, great, hello world program. So, very good, hello world program. Hello world, that was the first program, very good. So most of you will be, will start from that, from being hello world. So, okay, that's a great answer. So, whether an embedded system contains more number of processors? Yeah, an embedded system can have multiple processors based on the complexity. In case of rover, even still a rover, right, there will be multiple processors. Okay, we can have multiple processors in an embedded system. That's not a rover. Okay, moving on. So, hello. So, my question is, how do you manage to execute this hello world program? In Python or any language, how do you execute this program? In assembly language, okay, fine. Then, any other answer? Yeah, compiler, Jupyter notebook. Great. Yes. We have multiple answers here, compiler, yeah, turbo, CPP, lot of things. From your answer, I'm asking another question. What exactly is the compiler? What exactly is the compiler? So, the question was how to execute the whole program. My question is, what exactly is the compiler? Yeah, definitely a compiler will be to compilation. What exactly is the compilation? Yeah, so the tool that translate code written in high level language machine language. Very good. Got it. So I'm again coming back to my question. I'm again coming back to my question. So my question was how to execute or how do you execute the hello program? The question was on compilation. The question was execution. So when you use a compiler, what happens is that your high level language will get converted to machine language. So that's the responsibility of a compiler. My question was how do you execute a program? So that's it. Compiler is for compilation, right? So how to execute a program? So that's it. And functionalities motivated. Could you give me an example? Using more number of processors, so we mentioned about microcontrollers. There were no processors. So I got a question contains an Android system contains more number of processors. In fact, it's a controller. So when you mention a processor, the name processor is a general purpose processor. General purpose processors are not used inside embedded systems. They use microcontrollers or embedded processors. AMD processors. These type of processors are general purpose processors and they are not used inside embedded. In embedded system, we are using microcontrollers or embedded processors. Actually, a lot of questions are you got an answer regarding the conversion. And I got an answer from lower Indian PhD. What do you mean with that? What do you mean by
So, the given code will be for control and computer in terms of syntactical and analytical analysis. That should be loaded on the system. So that has to be executed by the system by its own, and that cannot be executed before the system can execute on the That's what I think. First, it has to be loaded. That has to be loaded on the system from the objects. So obviously, execute it's like the passing that is the environment of the system is given to
one of the IoT
how do you execute when you are dealing with embedded systems, when you are dealing with hardware, mostly aspect in these systems. Because when you use a laptop for performing hello or when you are using a laptop for doing application development, everything is straightforward. The tool will do everything automatically. So you will not understand what is happening. So let me summarize this to you. So when you type a hello world program, you will type this inside an IE. You will type the code inside an IE or a second IE. You type the code inside an integration development environment. Yes, for example, even the book programming, that's also an IE. And you mentioned about there is an accelerator, and inside the accelerator you are typing the program. There is a compiler. A compiler will convert the program to machine language, and there is a loader inside the language, and there are multiple related on the same software. That's why you are going to the integrated. So we installed the ID. So when you try to hello world program, behind the lot of things will happen. Okay, first what will happen? You will try the code. You will try the hello world code. The ID will check whether the syntactical error, is there a syntax error. The ID will check. So basically, you will be able to install ID, which is checking if there is an error or something. And then what will happen? The compiler will convert your final language, the program written system of equal to file to making language. Compiler will convert CMP equals to Python program to making language. Fine. So my question is the output of the compiler executable? Can you directly execute the output of the compiler? And based on the feedback, I will planning the rest of the system. Otherwise, you will not be able to go. So that's the only reason why I am insisting you to act. And we will do that. Based on this, I will be planning the rest of the system. Otherwise, we will not be able to complete the things properly. We will get confused. So the question is, can we execute the output of the compiler? That's what I said.
One minute, sir. If you want to ask any question, just intimate.
Not really.
Anyone? No. Just giving both the two-way communication is not possible. If you want to answer, tell me. You should mute here. Then you can ask. We have to operate like that. This is only the possible. Otherwise, disturbance will occur. So if you want to ask any question, answer, please tell me.
Okay, sir, we are receiving, sir. Messaging for this is very
That's why in case of hardware, in case of IoT hardware, in case of edge computing, this should not be unknown. Yeah, for a laptop-based programmer, for a desktop-based programmer, lot of things are unknown. So we should understand all the unknown things we have to understand. Anyway, after compiler, we got an output. It's not executable. So I was asking what is compiler's output is. You should understand. Otherwise, it's not possible to create and write. If you are just copy-pasting the code, it's okay. But when you design your own hardware, when you design your own software, you are not going to hold it. Okay. Anyway, I'll explain this one. So, the thing is, inside an ID, there are people, so we already mentioned, and inside ID, there is a compiler. We already mentioned that also. So, we reach up to making line. Up to making line is given. The compiler will convert higher line to 16 line. So, this is the and the next step, once I is the next. So, you have to convert the output of to inside the ID. Inside the ID, you that so after the compilation, the linking will happen. Okay. Output of the linker will happen. Okay. So basically you're moving the code in an ID, you're moving the code in an ID. And you're writing the hello world program, you're debugging the hello world program, and then you will actually execute button. The compiler will convert the hello world program to making language. The user will convert the making language to executable. That is what we have. So we want the executable stuff. After the executable file, we know. And what we have. You don't have any idea. The next step is done by the operating system. The operating system is the operating system. So basically, when you execute the program will be inside the hardest of the world. That's an open question for you guys. My question is simple. So when you execute the program will be inside the hardest for the world.
Such a mission, the object will be created. The object will be created. The image is an object. It will be created. But object will be
My question is, in an ideal, you will try the program. In an ideal, you will try the program. You will execute, you will combine the program. You will lead the program. All of it. The question is simple. When you execute a piece of code, when you execute a piece of code, the execution will happen from the hardest or from the necessary or from the that's the question.
Sir, CPU starts the expression, sir.
I'm going to answer your question. CPU will start the execution. That's what the answer given by so my question is, what are the CPU?
Actually, it's executed CPU.
My question is very precise. The question is very precise. The question is, when you execute a piece of code, the code will execute from the hardest or from the rest. That's the question.
So let us consider the channel access array. Sir, the executable file which has been created as an object will be there available. That has to be loaded back into the memory so that the execution starts. As we execute, the execution will be starting from the links where we can acquire all the data. We can go on process. Random access control.
Okay, fine. Let me check. I'll explain. Basically, when you open the Google, so assume that you're opening Google Chrome in your desktop page, and you have Google Chrome. It is software, and you will get a lot of videos. It is software, and you will get a lot of videos. Okay, and all these processes are consuming random access memory, which means when you execute a piece of code, and that code will be inside the random access memory. Okay, when you are executing a piece of code, that particular code will be inside the random access memory in the form of a process. And who is creating this process? The operating system is creating it. So when you execute a block of code, that block will be converted to machine language first, then it will be converted to executable file, then the execution will happen from the RAM later will be fetched by the process. So you mentioned about fetch, decode, and execute. All these things are correct. I'm not telling that it's wrong. But the flow is like you execute. The execution will happen from the RAM. The processor will take the data from the RAM. Why RAM? Because of the access time. To minimize the access time, instead of hardware, or instead of hardware, the processor will fetch it from the memory. So this is the overall. So I'll summarize for the next topic. To summarize, we started from a high level language to Python or any C programming, C++ programming, and we converted into machine language using compiler. Then we use the linker. Linker converted into executable. Then up to this the code is in the hard disk. Then what will happen? The operating system need to be the process. Okay, we have variable code. The operating system will create a process, and that process will be inside RAM. Okay, RAM. And from the RAM, the processor will execute the things, and we will get the data back. So this is the overall. So if there is any doubt in it, otherwise I will move to the next.
No, sir. No doubts.
Sorry. So, lower time is your break time. Moving on. So, the slide is lower.
Yes, sir.
So moving on to the applications. Moving on to the applications of the talking. So this comes with application. So this is an R tracker. So you can plug this device to your phone and you'll be able to track your digital application. This is another application. So any idea what this means? You know?
Energy meter, sir.
Okay. Is there something different about this energy meter?
Smart.
Actually, it's a smart energy meter. So it has got IoT capabilities. This meter will come to our house for meter reading, right? So this is automatic device. So you will be able to send the device will extract the current consumption and will send directly to the other one. So that you will get an automatic, you can generate the bill automatically. So that's the advantage of using such a device, smart energy. So these are the applications of Internet of Things. And basically, in any Internet of Things enabled device or any embedded system will be having multiple sensors. These are different types of sensors, and I'm not going into detail, but this is a very important part. So when you create hardware for Internet of Things, which all are the platforms available for creating IoT based hardware? So the most important thing is this. This is an ESP8266. ESP8266. It's a wireless microcontroller, and we can create IoT applications using Raspberry Pi. We can create IoT applications using Arduino by interfacing it with ESP8266. We can create IoT applications using Arduino Mega by interfacing it with ESP8266. And then comes the most important thing. We have an Texas Instruments MSP430 launchpad with IoT. So this is the TI launchpad for Internet of Things application. So a lot of hardware are available to us. So Arduino platform and Raspberry Pi platform for students is not possible for us to create products using Arduino and Raspberry Pi or ESP-based system. So when you are looking for an actual product development, whether to go for practical-based microcontroller, practical-based wireless microcontroller. So they are very cheap microcontrollers, wireless microcontrollers. So when you go for vector-based microcontroller, you are for explaining how you know. Yeah, sure. Yeah, I'll show you. Let me take
Professor, same action, sir.
Yes, sir.
Professor, no changes, same.
So when you get all the platforms, all the platforms,
That's why I'm not asking questions.
Ask the question.
Our applications. So when so when we discuss about actual industry IoT development, it's better to stick on to an industry ready microcontroller or an industry ready microcontroller. So this is IoT chips are available. So they are very cheap. The one is and you can purchase it and you can do manufacturing. So you can see NPA basically. It is manufactured by Turkey. So we have Turkey is offering 5 solutions. NPA solutions. So all these things are offered by Turkey. So when if you are really serious about IoT application, I suggest you to use Turkey. So I hope things are clear. Moving on. So this is what actually discussed earlier. So we have a microcontroller as well as microprocessor. The first one is a microcontroller, the second one is an embedded processor. This is a microcontroller and this is a processor. So what exactly is the microcontroller or microprocessor? So that's the next point. So whether we use a microcontroller and whether we use a microprocessor. So any idea? So whether we use a microprocessor and whether we use a microprocessor. No. Can we express behavior of behavior? Is it okay? Okay. Let me explain. So when both the inputs are high, the output is high. When both inputs are low, output is low. And any of the input is low, output is low. So this is the behavior of and we can clearly program the behavior, right? Let's assume that A and B are if A ampersand B equal to 1, how will happen? The output should be, or if A equal to 1, or if A equal to 1 and A equal to B equal to 1, output should be O equal to 1. So let us see the program the behavior of AND gate. First we program it to the network. Could you please give me the something of the network? Okay. So we can clearly program the behavior of an AND gate. Okay. As I said, if A equal to 1 and B equal to 1, then the result will be this. So like that you can program the behavior of the AND gate. And you can create a simulator of AND gate. So what I can do is the simulator in virtual world. So I need point out by one to simulator will be in virtual world. Okay. The simulator will take the input, process it, and give the output. Like the original system, which is behaving data. So simulator will copy the behavior of the original system in game world to us. We have flight simulator. So instead of directly going to flight, what will we do? We do simulation. So that the cache is out. So that the aspiring pilot will be able to learn something. To get learn some kind to get some hands-on experience without actually going inside the world. So this is the concept of flight simulation. Similar to that, there are a lot of platforms. Similar to that, there are a lot of platforms for simulating. Similar to one, there are a lot of platforms for it. So I will explain different platforms. We have multiple platforms available. We have ECGD platforms. For each microcontrollers, we have Proteus. For each microcontroller, we have Proteus. For Arduino platform, we have ECGD. We have Intercat platform. We have Boki platform. A lot of platforms. So we see what platform. And we go for a break now, it's 11 now. Okay? So we will take a break now and we'll come back after the break.
Control of microcontroller number game one million.
Innovating our third and legal center of state and
even though we are dealing with the internet. So other applications also not elasticity or we can use we have to use communication between those engines through Wi-Fi, LoRa, anything we can use.
Yes, sir. ಈಗ ಸ್ವಲ್ಪ ನಿಜ ಕಣೋ
ಸರಿ ಸರ್
ಈಗ ಹೆಚ್ಚು ಕಣೋ
interact பண்ணுங்க யூஸ்ஃபுல்லா இருக்கும் சிஸ்டம் கேளுங்க யூஸ்ஃபுல்லா இருக்கும் இன்னைக்கு நாளைக்கு உங்களுக்கு ஃபுல்லா ஆன்சர் தான் நாளைக்கு ஏதாவது தெரிஞ்சுக்கலாம் புதுசா நீங்க அதை சொல்லுவாங்க விடாதீங்க that's why they giving money no don't leave them that's why
NGO coaches, four coaches. Create like this.
That we should start the now. We should start the
Welcome back. Hope you guys are ready. Okay. So which platform you can use? Somebody mentioned about physical chat. Somebody mentioned about Google. So I'm comfortable on the platform. So which platform should I see? So that's the question. So that you'll be able to easily follow the things, see all the functions. Which platform you prefer? We use this one. So, since you guys want to cover the basics of adding and all, that's why I'm asking. So it's not, it was not the plan actually. So my plan was to directly start IoT. Since some of you guys are not familiar with Arduino platform, it's better to learn that also. So, flexibly understanding the process. So that's why I'm asking, or can I proceed with some platform, primarily technical platform, so having the you. Can I select one platform and proceed? Module. Module. Could you please give me feedback whether I'm audible or not? Yes, sir. So which process? My question is which platform should I speak on to? Any preference? Or simply single locally? Okay, so you are not responding to something. For thousand I use internet. And for IoT stuff, advanced stuff, the MQTT stuff, all those things we use locally. And I'll use multiple platforms. I'll use Node platform. All those things I'll use. So we'll use 3 platforms for my control of this program. Is that okay? If it's okay, could you please let me know the chat box or earlier on the may to be.
Yes, sir.
Okay. Moving on. Okay, so we will talk, we will discuss about fingerprint, we will discuss about, we will discuss about Node, and we will discuss about multiple other platforms. And we will start from the fingerprint. We will start from the very basics of fingerprint. We will cover the basic aspects using fingerprint. So then we will move on to robotic as well. Okay. So this is the platform, and I have shared the link to the fingerprint platform. You can go and register in fingerprint. Now please don't do anything. Okay. Now, please don't take fingerprint. Okay, please listen. You don't need to do any other thing. Just listen. Is that okay? Could you please take the hands off from your keyboard and mouse? And well, please listen. Otherwise, you will miss the goal. Okay, okay, fine. So, I'm not explaining. You are able to see the screen, right? This is a microcontroller. Okay, this is a microcontroller, and for a microcontroller, there will be multiple pins. There will be multiple pins for the microcontroller. So, those who are familiar with microcontroller, could you please let me know the name of the pins? In general, which all pins will be microcontroller will be having which all pins? So, for those who are familiar with microcontroller. Because for IoT, the hardware is very important. For those who are not aware, yeah, we have VCC and ground. Plus and minus we have. ground we have then. VCC and ground is okay. Ground VCC, yeah, that's okay. In Sai Krishna, you need to he said, you can make it bit more general. In general, there will be physical ground and there will be a research. Then the most important thing. Nobody is mentioning that. Reason is okay. PCC ground and reason is okay. Then the most important one. Okay. Then that's not important. The most important thing is something different. Okay. Anyway, you can listen now. So we have VCC ground, VCC, all those things are there. But the most important thing is this one, GPIO, right? GPIOs. What exactly is GPIOs? It's not general input. GPIOs. What exactly are GPIOs? GPIOs are general purpose input outputs. General purpose input outputs. GPIO is general purpose input outputs. So we are covering the very basics of microcontroller. Please listen. So those who are having computer science background will not be aware of all these things. So for creating IoT, it is mandatory to understand this one. GPIO means general purpose input. So you can see here, we have, you can see here one, two, multiple things are here. There are things here, and these can be these concepts or these things are GPIO, GPIO, this is GPIO, this is also GPIO. So there will be multiple GPIO. Okay, lot of GPIO will be available in a microcontroller. So what exactly is GPIO? GPIO means general purpose input. So let's take the example of GPIO. So this is a microcontroller. Assume that these are GPIOs. These are GPIOs. Okay. So these are GPIOs. So why we are using GPIOs? GPIOs means general purpose input outputs, and those things can be configured as an input or output. GPIOs can be configured as an input or output. So that's the advantage of using GPIOs. So assume that I want to connect this is a microcontroller. And this is the LED. So this is a microcontroller, this is an LED, and assume that this is GPIO pin number 1. GPIO pin 1. Okay. This is GPIO pin 1, and this is microcontroller, and this is LED. So how will you configure the GPIO? So I want to turn on, I need to control the LED. I need to control the LED using a microcontroller. I want to bring the LED using microcontroller. I want to turn on the LED using microcontroller. So this is pin 1, GPIO pin 1. So controlling the LED using a microcontroller, I will configure the GPIO as an input or output. That's the question.
Otherwise, what?
It should be either on or false. And I should control the LED using my control. So I will configure the GPIO as an input or output. That's the question. I'm not going to do it. Yeah, I wrote one answer. I wrote another answer was both. I don't know why you are saying both. So that's what I asked. That's what I asked. If you don't know the concept, then it's very hard to use IoT. You should understand this too. Otherwise, it's not possible for me to teach IoT system. This is very important. The basic thing is very important. LED is output. Yeah, great. See other LED is output. LED is output. What about the microcontroller? GPIO is not microcontroller. Anyway, I'm not explaining. So we have a microcontroller. We have a microcontroller here. And pin number one, GPIO pin one is connected to GPIO pin one is connected to which GPIO pin one is connected to LED. Okay. GPIO pin one is connected to LED. So to control this LED, using this microcontroller, we'll have to configure the GPIO as GPIO should be configured as GPIO, GPI1 should be configured as output. Okay. GPIO1 should be configured as output. Then only we can control GPIO1 should be configured as output. Then only we can control the LED. So you can see this. The microcontroller gives out the signal to LED for people around. So the microcontroller sends what? Microcontroller gives something to LED. What? For turning on microcontroller, we should give something. So what exactly is that? Could you please let me know? To turn on the LED, microcontroller should give something. You know? Getting the question right. Yeah, I'm going to have output here. Microcontroller needs high output voltage. Okay. How much is the voltage? Your answer from the is 5 volts. Okay. So I hope some of you guys know the concepts. Anyway, coming back. So this is a microcontroller. This is an Arduino platform, and this is a microcontroller. And this is the GPIO, as I mentioned. A microcontroller we having multiple pins, and we are calling it as GPIO. A lot of special pins are there, and one of the important thing is GPIO pin. And we have multiple GPIO pins. GPIO 1, 2, 3, 4, 5, 6, 7. A lot of GPIO pins are there, and one of the pins is GPIO 30, GPIO 30, 12, 10, 11, And lot of GPIO features. Why we are using GPIOs? GPIOs can be configured as an input or output. To give out data, we configure GPIO as output. To take data from outside, we configure GPIO as input. My intention is to bring an LED. My intention is to bring an LED. For bringing an LED, we have to configure the GPIO as output because we are giving out something to the LED. For example, is there something? The something means the voltage. So here, the microcontroller will produce the voltage. In the case of Arduino, it will be 5 volts. In the case of Arduino platform, it will be 5 volts. And in the case of the ESP platform, it's 3.3. So depending on the microcontroller, this voltage will change. Okay. So basically, we will be giving out voltage at this terminal. So by using program, you can give out voltage at this particular terminal, GPIO 30. Okay. So the GPIO 30 will be first, we have to configure GPIO 30 as output. To license the LED, we have to give out 5 voltage to GPIO 30. So this is how GPIO is configured as an output and we can control the LED. So we'll go to the code. So the code is visible, right? You can see the code, right? So visible.
Screen cover visible. Google path. Hey, Google Meet visible out there.
Is it visible now?
Sir, okay, sir.
The screen cover.
So my intention, what was my intention? My intention is to bring the LED. My intention is to bring the LED. So what exactly should I do? First, I will have to configure the pin as equal to 3.0. So we are configuring pin number 13 as output. GPIO is configured as output. That part is done. Then you will have to value. Okay. So here we have to write 5 data. So inside the microcontroller, inside the code, we will not mention 5 volts. Okay. We will mention high and low. Okay. High is 5 volts, low is 0 volt. In case of microcontroller, which is a 5 volt command, how is 0? So digital light is high, digital light 30 is high, digital light 30 is high. So when we execute digital light 30 is high, what will happen? You will get 5 volt. You will get 5 volts at 13 pin. You will get 5 volts at 13 pin and LED below. And when you write digital light LED below, you will get 0 volt at that pin and you will get LED above or LED below. So this is how you turn on and turn off the LED. So how do you guys have done this program in your game? So if you have done this program, we can skip this part. Or if you are very new to computer and you are first time experiencing this, we will wait for some time for trying out this in your class. So, do I need to spend some time? Your first time. So if your first time you do one thing, you log into the game and share the details. Okay, you log into the game and create an account. And I help you to revise the create a certain something. So that will be good. So your first time can do. Otherwise, when you in the afternoon you are moving to public complicated stuff. Otherwise, MQTT and Google and all. So we will be confused. So for the time being, you just try to log into the and wait for my instructions. I will help you all to run this service. And to be for the first time, okay. If you know, that's okay. Okay, ma'am. I'll help you. I'll let you know how to do. Just listen. if you're done creating the account, please click on OK. And this is for the one who don't know about Twitter, okay, and they are posting in the chat box to explain the Twitter. So that's why I'm explaining. So you guys please cooperate. Stop whatever you are doing. Stop whatever you are doing and then listen. Okay. Stop whatever you are doing and listen. Listen, please. So when you log in to the web, you will get something similar to this. Okay. When you log into the web, you will get something similar to this. So what you need to do, you have to click on create circuit. You have to click on create and then circuit. Please don't do it now, okay? Please don't do it now. Just listen. Create circuit. Log into the web and go to create circuit. And you will get a window like this. Window like this. So we can drag the additional flag. So here in the side panel, we have multiple platforms here, multiple components here. So from here we can take the additional flag. So just you don't need to drag the component. So just click here and click here. That's it. So you don't need to drag it. Okay? So you get the platform. And then you will have to select an LED. So here is an LED. Okay. Place the LED. And after placing the LED, we have two terminals. You can keep the mouse here. So this is cathode and this is anode. Cathode means positive, anode means actually cathode means negative, anode means positive. So this is the value. So cathode should go to ground, anode should go to 30. So just click here and connect it to 30. Okay. So it go connected to pin number, sorry, not 30, should go to ground. Okay. Select here and connect it to the ground. So now the LED is connected to ground. Then anode should go to 30 through a resistor. You should use a resistor here. Because since it is 5 volt to keep the LED. Okay, and to limit the current, we have to use the resistor. Resistor should be 30. This is how you do the circuit. And now how you do the coding. For coding, you can open the side panel code and change the blocks to text. Blocks convert to text. Continue. So you will get something like this. Okay, the code will automatically come. Okay. So you can start simulation. So here you can see the LED building. So this is how it's done. So now we can start doing this. So once it is complete, please let me know. We proceed to the next step. Please start doing it. And once it is complete, please let me know. And if you have any doubt, you can ask me and I will repeat the steps. So one member working, let me know when you proceed. If there is any doubt, please ask me, and let me know when to proceed.
Sir, complete this, sir.
Please let me know. We will leave the chat also. All are ready. We will continue to the next part. Or if you want to repeat, I will do that also.
Blocks in external. External. Blocks. Blocks. Completely external. Start the simulation. JP. Start simulation. Shankar, IoT expert there. IoT expert, IoT, what is that? Elita? Yes, gold, silver, platinum, silver.
Okay, I confirm most of the questions are complete. And team trainings will continue. In next 3 minutes, we will proceed to the next question. Okay. So if someone is team training, please continue. So actually, if I was there, I come to your place and check whether it's working or not. And online meeting and able to understand whether you are coding or not. So please give me feedback. If something is wrong, please ask. And those who have completed can help others also. Those who have done this job, you can help your partner or help your colleague.
Okay, sir.
So,
Okay.
Most completed put in chat completed. Please request you that. ESP, that's it. Jetson. Jetson. Yes, sir. Jetson. Advance of see, ಇದೆಲ್ಲ ಯೂಸ್ ಮಾಡಬಹುದು ಪ್ಲಾಟ್ಫಾರ್ಮ್ IoT ಕೂಡ ಎಕ್ಸ್ಪೋರ್ಟ್ ಮಾಡ್ತಿಲ್ಲ ಏನು ಎಕ್ಸ್ಪೋರ್ಟ್ ಸರ್
have already done this, that we have done many businesses. Sir, what tell me?
ಇದೇ ಚಲೋ ಇಂಜಿನಿಯರಿಂಗ್ ಮಾಡಿದ್ದು ಫಸ್ಟ್ ಹಾಕೊಂಡು ಸೆಕೆಂಡ್ ಹಾಕೊಂಡು
And for those who have completed the design, I'm sharing a link.
Sir, in that was your link, just click the link, it will automatically go to that page, respective explanation page.
Yes, sir. Yes, sir.
Automatically direct to that respective page, explain page. Copy the ticker. In that page is copy ticker is there, na? So if you click copy and ticker means you can create a score in your name. Copy and ticker means you can copy a new file from that. Copy and ticker. So copy and ticker. Copy and ticker. Copy
Okay. So you are able to see the screen.
not final.
Is it visible now? So I'm going to the next part. So now, what we do, we use the microphone, we use the LED, use the microphone, and we use the LED, and we manage to control the LED in the payload. So I was and he was the problem and I was the problem. Now what we are trying to do, we are trying to do the opposite thing. So this is my microcontroller. This is my microcontroller. And I'm going to use switch. This is actually like this is the switch. So we configure the input. This is the butter. Butter means LED. Using we gave out the data from microcontroller to LED. For lighting of for lighting an LED, we gave out the data to the LED. And in case of a button, but it's just a switch, right? The switch. When you are interfacing a switch, how should we configure the detail? I think input or output? Anyone give a response? Already response. Yeah. So when you interface a button, you have to configure it as an input. Okay. So should be like this. The data should come from button to microcontroller. So that's exactly what we are going to do here. When you open the link and you click on copy and finger, click on copy and finger and you will do something like this. And let's discuss about the code. Code is simple, right? This will code is okay, so button is two. The button is connected to which pin? Pin number two. And this is connected to which pin? Pin number three. Okay. Button is connected to pin number two. Button is connected to pin number two. And this is connected to pin number three. Okay. Here we are not connecting the because in pin number three we have an onboarding link. This is an onboarding link. This one is an onboarding link. It is connected to pin number 13 internally. Internally it is connected to pin number 13. Okay, so you don't need to use the external link. If you want to use the external link, you can use it. Like that we did the forward area. It will work. Okay. You can just drag and copy it on the external. It will work. Even if it's not this external link, the onboarding link is connected to the link. So I think this is the link. Okay. But it's easy. So here you can see. Individual is configured as an button is configured as individual is also then in the forward code we did what we did is digital write. Digital write some value to the read. And in this case what we are doing is digital read. We are reading value from the button. We are reading state of word. Okay, so here we are using digital read. So if button state is high, digital write will be high. If button state is low, digital write will be low. So this is a very simple code. You check whether the button state is high or low. If it's high, the LED should go high. If it's low, the LED should go low. So that's what we do. So we have to start simulating and press the button. So when you press the button, what we have? When you press the button, the LED will light. You can see the LED lighting up, right? Press the button, LED will light. You can write your imagination. So this is just an LED light something. If the green dot asks, then it will
What does it mean? Pressing.
click on the link and select copy and finger. You just go about
Actually, here while pressing the button, LED will on. LED will on. If you take not the hand, automatically it will off. Like this, the concept. Even
then we will afternoon session we will talk about the normal and all.
Sir, if any queries, please ask me, sir. Actually, in that coding, please go to the coding. In that coding, they mentioned pin number 2. Pin number 2 is the push button connection. Then they give pin number 13. If example, instead of 13, we give 10 bits, we have to connect the LED with 10 bits. Likewise, you can modify the program. If you want, you can.
Now we are moving to the very advanced
ಏರೋಪ್ಲೇನ್ ಇದೆಯಾ
Before that, you are not done, let me know.
Sir, please actually reset button to the LED given that in that is our desire number of number 1 to 13 push button to 5 is okay. For LED give you some but the coding not listed.
This is going on the important part, the advanced part. Hello, sir. Hello, sir. Definitely right. Okay. Okay. IoT accelerator, another accelerator for networking. This is a need of now. Now we are moving on to AI, and we are trying to combine IoT and AI. So this is very, very important. How to deliver hardware accelerator for networking. So now we know, for example, IoT. So as I mentioned, IoT an IoT system or an IoT architecture, there are embedded systems. These IoT nodes is an embedded system. You can call it as an embedded system. The beautiful embedded system. These IoT nodes will be embedded systems. There are many nodes in IoT nodes. In general, IoT nodes are embedded systems. Local and the local IoT is not embedded system. So this is the overall market. So this is a traditional IoT node. In a traditional IoT node, there will be a microcontroller, there will be Wi-Fi, there will be power management node, there will be analog digital converters, there will be memory, there will be sensors. So this is a traditional IoT node architecture. Okay. Consider the case of the EV. Consider the case of electric vehicle. This is autonomous. Autonomous EV. So now it's a clear of autonomous EV. So basically we have autonomous EV self-driving driven by us. Consider the case of autonomous EV. So in case of autonomous EV, with such an architecture work. Is there any problem with this architecture? Is there autonomous EV? Anyone? Do we understand? So the question is, this is an traditional IoT market. So you know most of the cars, most of the EVs, most of the self-driving cars are now using IoT technology. So when I'm using a traditional IoT architecture in modern EVs, which is self-driving, doing that work. It's okay to use the traditional IoT architecture in a self-driving car. This is an EV. So what's the problem? What's the problem with that? What's wrong? You think that it's no. What's wrong and what's the problem when we use this kind of architecture? Advanced multitasking, okay. Multitasking can be done using microcontroller. If a microcontroller is you can do multitasking using microcontroller, it's fine. But there is an important thing. Okay. So I'm going to explain that. This is very, very important, and this will be useful. Actually, the future is this. So we'll have to leave the microcontroller aside, and we'll have to use something else. So that's what we'll do. So let's see. So when you are using a traditional IoT node, the IoT node will be a low capability node. So we discussed that a microcontroller is IoT node. It's a low capability node. No, okay. The capacity or the processing power of the microcontroller will be low. Okay. So in that scenario, if something complex is there, if some complex data is there to compute, or if something complex is there for computation, the low capability node will send the data to cloud, and the cloud will do the processing and it will give back the result to capability node, low capability node. So this is the traditional architecture. Now you will get an idea. Now you can check the architecture and let me know what exactly is wrong with this circuit. In this aspect, so we'll just check this. So this is a hint for you to answer. So based on this scenario, what exactly is wrong or what exactly is the limitation? In this scenario, this is a hint for you guys. Anyone? Okay. I will explain. Not over, I'll explain. So consider the case of an autonomous car. Consider the case of an autonomous car. So you know the autonomous car is driven using LiDAR and cameras. So assume that there is only camera. Assume that there is only camera and an obstacle sensor. Camera and as well as an obstacle sensor. So what we have? So when you are driving the car, the camera will scan the images, obstacle sensor will check for obstacles. And then what we have? Since the camera piece is very complex and image processing is very complex, what will happen? The traditional IoT node or normal IoT node will send the data to cloud for processing. And the camera will let you know something is standing in front of you. And the cloud will give back the data to the inform that please stop something is in front of you. So when you are dealing in that way, the latency is not really high. The low will send the data to cloud for processing. Cloud will process it and give back to the EV. So there will be a latency from vehicle to cloud and cloud to vehicle. There will be a latency. So is that desirable? This latency. If someone is standing in front of your EV, what will happen if your network is down? Your network is down. What will happen? Someone is standing in front of your EV and you're driving your EV. Suddenly somebody accident will happen. So some network problem arises for business. Definitely, you will hit the person standing in front of you. So that's the problem with this particular architecture. Okay. This is a low cost architecture, but but the latency is very high. And if something happens with the network, accident will happen. So this is not suitable for EVs, or this is not suitable for self-driving EVs. Okay. So which one is suitable? Moving on. See, desirable. What exactly is desirable? IoT want edge computing capabilities. Okay. Edge computing. So edge computing is the solution. Cloud computing in case of EVs and not in case of EVs, self-driving cars, edge computing is the solution. Okay. You should do maximum computing from the IoT node itself. And you don't need to send the data to cloud and do and take it back. So everything will be done inside the and take it back. So everything will be done inside the IoT. There will be minimal communication with the cloud. Okay. So as I said, the first reason is we have now the hardware. We have a highly capable hardware available at present. So then we are why we are going to problem if the processing, if you can do the processing standing inside the IoT node, then why we are relying on cloud? So we have a very high performing hardware available in the market. So use that hardware and do the processing, do maximum processing in the IoT node. You don't need to go to cloud. So that's the reason. Then comes the real-time system. So self-driving car is a real-time system. So if you are taking feedback from the cameras and you to the cloud and taking feedback from the cloud, you may create action. So that's not a good solution. So real-time system. So there's a requirement for real-time systems. That's why you are using edge computing for IoT in the case of electric vehicles and autonomous cars. Okay. So this is the scenario. Edge computing is the scenario now for EVs and autonomous cars. Moving on. So as I mentioned, this is a real life scenario. So when this happens, definitely we have to rely on edge computing. Are we sure? PhD is AI based.
Not a day.
Okay, I don't know. I asked a basic question, so you can read the chat box. Multiple answers, different answers. Mark or no AI components there. AI is a virtual machine that can perform some work for you. A real life example of AI. A collaboration.
That are performed.
Okay. You don't need to use AI. There is a tool on OpenCV. Using OpenCV, you can do image processing. No AI is needed. You can do number detection, object detection. Everything is there. You don't need to worry about. So the exact information. Traffic CCTV in Bangalore. Transport, military. A lot of people coming actually. I'm still not getting the exact point. I'll summarize. Okay. So basically, I'll ask one more question, and after that we will come. So that question is, just now we wrote a program to control the LED. Okay. Just now we wrote a program to control the LED. Turn on and turn off. Turn on and turn off. Is there an AI element in that program? That's the question. No AI elements. Okay. There is no AI element. Fine. Okay. Okay. So, move on. There are no AI elements in the program as you mentioned. Move on. Assume that for a computer program, I'm mapping A to 1. I'm mapping A to 1, B to 2, C to 3 in the code. Assume that I'm writing a code and I'm hard coding A to 1, B to 2, C to 3. Basically, there are three inputs A, B, and C. When I give input as A, the output will be 1. When I give input as B, the output will be 2. When I give input as C, the output will be 3. So when I give input D, what will be output? In a system, when I give input as A, output is 1. Input B, output 2. Input C, output 3. When I give output D, what will be the output? Okay, 4. Okay, so how you do code it? So how you write a code for that particular application? How you going to do that? How you write the code for that particular application? So that is the difference between human intelligence and artificial intelligence. So how you write the code? A is 1, B is 2, C is 3, D is 4. That is human intelligence. Only we can predict that. Okay. A is 1, B is 2, C is 3, D is 4. That's our intelligence. How you make your machine do that? So there we will have to artificial intelligence. Prediction. It's a prediction. We are not hard coding it, right? We are just hard coding A is 1, B is 2, B is 3. When we get a new input which is not there in the data set, these are our data. A is equal to 1, B equal to 2, C equal to 3. This is our data. These are our data elements. These are our data elements. But B is not there in the data. D is not there in the data. So even when D comes, the system will predict it as 4. This is the basic artificial intelligence. Hope you got the concept. Am I, is it clear? Great. So when you talk about artificial intelligence in layman's terms, this is the system predicted based on the data, based on the data analytics, based on analyzing the data, analyzing the available data, the system predicted something which is not available in the data. So this is the concept of AI. Okay. There are other concepts also. So handwriting recognition. So basically we know 1 to 10. We can write 1 to 10. But handwriting is different. Our handwriting is different. So recognizing the multiple handwriting, we can't just compare. So we have to do pixel math. So that can be done using artificial intelligence, using some filters. Here also the data, available data, what I said is available data. So what I said is input data. Input data is new. Available data is there in the data set, okay fine. But input is always new. So based on the new input, it's giving the output. So this is the concept of data. Okay, I hope this is clear. So is it clear? Can I proceed?
Sir, actually, in mathematical model, it is also considered a model.
You can limit the animal behavior using AI, but it's not feasible now. Using present computational platform, using the available computation platform, there is no strong AI. We are still in weak AI. We are not even able to touch human intelligence. We are just 10%. Remaining 90% is left. We are still in weak AI. Strong AI is yet to come. So we can't replicate human intelligence. We are still in weak AI. So when you bring strong AI phase, everything is possible. You can replicate human intelligence, you can replicate animal intelligence, everything is there. But still we are struggling because of the computation power. After the quantum computation, maybe this will happen. AI inference. So I'm making the concept here. So without understanding the concept, if I'm simply coming and telling NCCD, AI, and all those things, will be based on that. So that's why I'm trying to make the concept here. So moving on. So one part is over. So what I said is AI. The way term AI, the meaning of artificial intelligence. So we got an idea now. We got an idea about that now. Now coming to AI inferencing. What I said is inferencing. So that's the question. These are all basic terms. So these are all related to that actually. So if you don't know it, I'll explain. So let me know what I said is between.
Actually, the thumb rule behind that logic. Sir, I have a thumb rule behind the logic.
Directly telling please explain. So I don't need to wait for your feedback. If you don't know, just tell me please explain. I got feedback from can do 90 feedback. Three type of inputs. Which are all the inputs? I'm not asking about the light. Just let me know what type of inputs. I just want to know what exactly is inputs. Like it's not about types. Great. And do so, let me explain. So, let me go back to the previous example. A is 1, B is 2, C is 3. So, these are our data. These are our data. A is 1, B is 2, C is 3. These are our data. When D comes, the system should consume that or system should map to 4. When D comes as input, the system should map to 4. And this procedure is known as inference. This procedure is known as inference. So basically, the AI engine or the AI model or the machine learning model will give out the data or consume something from the existing data. Analyzing the existing data, when new data arrives, it will give out a conclusion. This procedure is known as inference. Okay. Yeah, that's correct. Inferencing is expecting something from some truth. Very good. That's a clear definition. Very good. Basically, based on the available data, when a new data arrives, the machine learning model will, or the AI model will give out its prediction or its conclusion. So the procedure of concluding something from the available data, when a new data arrives, this procedure is not inferencing. So this inferencing is happening in the edge device. So that's the concept. The inferencing will happen in the edge device. So we will deploy training model inside the edge device. We will deploy training model inside the edge device. Basically, the training will happen in a workstation. The training part will happen in a workstation. And after that, you will get the training model. You will put the training model inside the edge device. Why is like that? Can we do the training as well in the edge device? Flowing the training model in the edge device. Why like that? Anyway, just check the image in the screen. Check the image in the screen. So we have enormous data. We started with the data. Okay, there's huge data available outside. Real life data, huge data. Okay, and then we will develop a model. Okay, then we will train the model using requires heavy computational power, heavy processing power, and it's time consuming. It will take nearly, if it's a complex model, it can take even days to train the model. 10 days, 20 days, 30 days, even 1 month to train for development model. It is complex. So that procedure, for doing that procedure, heavy computational power is required, high power computational platform is required. So training the model, the training happens in one station, high power station. Okay. And after the training procedure, we will get the trained model. So we will take this trained model and put it inside our IoT HDO. So the trained model will go inside IoT HDO. So the advantage is you can accelerate the training. Time. So when you are doing it in an edge device, when you are doing training inside an edge device, it will take months to complete. So when you are using a workstation for training, it will take 2 or 3 days or even a month to complete the training. So that's why we are training the model and we will only deploy the trained model and inference engine. Okay, or your IoT hardware. AI power Is it clear? Up to this, is it clear? Please let me know. I go forward. Great. Fine. So moving forward. So what I'm trying to teach you is, using the modern technology, using the recent cutting edge technology, how to create or how to intersect or how to amalgamate AI and IoT. How do you do the amalgamation of artificial intelligence and single topics? So there comes the use of hardware accelerator. Hardware accelerator. So why we are using hardware accelerator and all those things on the next page? So, so you have hear about image processing. So you know right, image processing tasks are a lot of things into object detection there. And so assume that I'm trying to create a hardware for object detection. So basically there will be a camera, and when you keep an object in front of the camera, what will happen? The camera will check the feed and it will let you know exactly is in front of you. It may be an apple, it may be a dog, it may be a human. It will detect. So this is my application. So assume that you're doing cloud computation for that. So you will take the camera will take the camera feed, and the camera will go to cloud, and in cloud it will compare, and the result will come back. So there will be like this. To avoid this, we will integrate an inference engine to the camera. What will we do? We will integrate an inference engine to the camera. See here we can see. So this is the camera, and here there is an inference engine. So which means camera is on the same module, inferencing is on the same module. You don't need to rely on cloud. So when you show a dog in front of the camera, the hardware will let you know it's a dog. When you show an apple in front of the camera, the hardware will let you know it's apple. So you don't need to rely on cloud. The inferencing will take place where? Inferencing will take place where? In the device, so you don't need to rely on cloud. So that's why we are using AI accelerators or accelerators for inferencing. Accelerate. So ASIC means application specific integrated service. Application specific integrated service. That's when application specific. For one particular application, you are creating that. But there is a problem. When we use application specific integrated circuit for AI inferencing, there is a problem. So don't let me know that. For example, is the problem. When we use ASIC or fixed IC based inference engine, for example, is wrong. You do not agree. I'll explain one thing. Before, so that's what the problem actually. So basically, you should know understand what exactly is an ASIC to answer my question. So if you don't know what exactly is an ASIC, then it's going to be very hard for me to teach you this kind of answer. So ASIC. So do you know what exactly is ASIC? Application specific integrated circuit. Anyone? Who's going to tell me an example of ASIC? ASIC, oh my god, ASIC is actually it's not a language actually. ASIC means application specific integrated circuit. Right? It's a chip. ASIC means a chip. Okay. Fine. Okay. Just understand this. I'll explain. So when you go for some events outside, I think there'll be a lot of small LED based stories, right? Have you seen that? Small LED based stories. When you click a button, it will be like in different patterns. Have you seen that? Simple LED based stories for symbols. When you click the button, the light will change. When you click another button, the light will change. Again, you press button, the light will color will change. And you will get multiple patterns. Have you seen that? The toy, LED lighting based stories. Anyone? Yeah, I got one answer from Chandu Ram. And what about the rest of the you have you seen the story? Anything? Yeah. I'm just trying to relate. I'm just trying to relate. So how that works? How that works?
Sir?
So there is no microcontroller. Okay. In that particular circuit, there is no microcontroller. So there is an IC, there is an integrated circuit. Oh my god. FPGA itself will cost 2,000 to 4,000 rupees. And how can you integrate that in FPGA? In a toy. You're thinking about a toy. How can you integrate it? So that it's not an FPGA, it's just an ASIC. Just an application specific integrated circuit. It's a chip. It's a chip designed exclusively for lighting of the LED. So in that law, there is a chip designed exclusively for lighting of the LED. And that's why when you click a button, the light color changes. So this is the concept of ASIC. ASIC is an IC. ASIC is a chip which is designed to perform an application specific task. Okay. So now you got an idea about ASIC. Is it clear? Okay. So assume that I'm gonna create a chip for AI, an ASIC for AI. Assume that I'm gonna create an ASIC for AI. What exactly is the wrong in that? When I create an ASIC for AI, there are some problems. Could you please let me know the problem? Anyone? Very good. Very good. AI, when you create an IC for AI, the problem is each and every month or each and every year, AI is evolving. When you create a chip for AI, each and every month, each and every year, AI is evolving. New and new models are coming. You know, right? You know about multiple AI architecture. You have ResNet, you have UNet, you have WNet, you have a lot of AI-based models available for different applications. And new models are coming. GAN models are coming. Lot of models are coming. Okay. So every month research is happening. Every year new models are coming for different applications. So the problem is when you actually chip design is a time-consuming task. So it will take nearly an year to create a chip. So when you create a chip for AI, what will happen is by the time it's coming or by the time it's coming out as a chip, your state of the art will become obsolete. Your AI model will become obsolete. So it's not a good idea to create a chip for AI. Okay, ASIC is not a good solution for AI. So what exactly is the solution? The solution is always reprogrammable hardware. Okay. So move on to that. Based AI accelerator. We can design FPGA field programmable gateway for adaptive computation platform based AI accelerator. ACA for FPGA field programmable gateway. For GPU based accelerators. The problem with CPU and GPU accelerator is CPU will go at the speed. So there will be always a throughput difference. So this is a problem with CPU, GPU or CPU based accelerator. And what about FPGA based accelerator? In case of FPGA based accelerator, everything will be in parallel. So AI inference as well as the performance critical functions will be in same. There will be no bottleneck. Both of them will do well. Both of them execute in. So you don't need to worry about this process. So I'll explain daily. So now is the time for the lens breaker. I'm going to remember. Something is the lens breaker. So 1:30. At 1:30 we are going to, yeah, I will explain. And afternoon we can explain. Okay, then we go for lunch break and we will come back after. And afternoon I will explain about FPGA and I will explain about how to program FPGA. Then we will go for NUPGA. The very important thing. And finally we will go. Thank you. Thank you.
Basic level tries to I don't